All right, fundamental theorem of algebra. Kind of bring a lot of stuff that we've done to somewhat of a close. Fundamental theorem of algebra says that every polynomial of degree n has exactly n solutions. So what that means is what we've already talked about. If you have, say, y is equal to x to the fifth minus 2, even though it appears very simple, it has 5 solutions. 5 solutions. The solutions may exist of real solutions and imaginary solutions. So we say it's a total of n solutions. Every polynomial with coefficient a, solution c sub 1, c sub 2, c sub 3, c sub n, can be written in the form of p of x is equal to a times x minus c sub 1 times x minus c sub 2 times x minus c sub 3, so on and so forth, all the way to x minus c sub n. What that is saying is that every polynomial can be factored. And we're going to show that every polynomial can be factored. And finally, if polynomial p of x has a solution of a plus bi, so a complex solution, then another solution must be a minus bi. That is the conjugate. This means that complex solutions come in pairs. They are conjugates. Things to keep in mind. So let's set out to do this. I'm going to differ from the directions just a little. We have our total solutions. We have our positive real. We have our negative real. We are going to have our total real. We are going to have our imaginary. We are going to have our choices within the rational roots theorem. Remember solutions. And we are going to have our factored form. These are all the pieces that you should be able to list and diagnose in a problem like this. It says p of x is equal to x to the fourth minus 16. Because of the exponent 4, it has a total of 4 solutions. The number of positive reals equal to the number of sign changes. There is 1 sign change. The number of negative reals is equal to the sign change under p of negative x. Notice that p of negative x is still x to the fourth minus 16. As you see there, there is 1 sign change. So because there is 1 positive real and 1 negative real, that means there are 2 total real solutions. 2 total real solutions. If there are 2 total real and there are 4 altogether, that means that there must be 2 that are imaginary. So these 2 added together must give you that one. Okay. If we worked out the rational roots theorem, we'd see our choices are plus or minus 1, 2, 4, 8, and 16. Let's find the solutions. You can use the rational roots theorem, or if it factors, that might be an easier option. This factors to x squared minus 4 times x squared plus 4. X minus 2 times x plus 2 times x squared minus or plus 4. Notice we have 2 solutions already. We have positive 2 and negative 2. If I solve x squared plus 4 equal to 0, I get x squared is equal to negative 4, and as I square root, I get x is equal to plus or minus 2i. So we also have positive 2i and negative 2i. Those are my solutions. They match up identically with 1 negative real, 1 positive real. That's 2 total real. That's 2 that are imaginary, 4 total solutions. Notice how positive and negative 2 show up there. the factored form of x to the fourth minus 16 is x minus 2 times x minus negative 2 times x minus 2i times x minus negative 2i. Now, I know that many of you don't want to write it as subtraction like that, but that's what the fundamental theorem of algebra says, that you subtract all of them. Now, this is totally fine to write it like this. Whoop, sorry. That's my mistake. X plus 2, x minus 2i, and x plus 2i. There you have it. So what that tells us is that it can be written in factored form. The reason why I wrote it out like this first is we're going to use that later on. So that's our first example. Let's look at our next one. Our next example is, we identify the total again, our positive real, our negative real, our total real, our imaginary, our choices for the rational roots theorem, and our solutions, and we are going to write it in our factored form. So those are all the things that we're going to do. Notice that the total real is 3 due to my exponent. The positive real is 0 because there are no sign changes. If I plug in negative x, I get p of negative x is negative 8x cubed plus 1. There is one sign change. Therefore, there is one total real because 0 plus 1 is 1. If there is one real and there's 3 total solutions, that means 2 must be of the imaginary or complex form. My choices, I have 1 here, I have 1, 2, 4, and 8 there. So we have plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. This is one that factors as well. It is the sum of cubes. And so we have 2x and 1. We square the front. We square the back. Multiply the 2 together. Last is always positive. This is the same sign as what we started with. That's opposite. So as we look at that, we can see that negative 1/2 is one of the solutions. And so we get negative 1/2. Notice that that is my negative real, my one real solution I have. The other 2 are imaginary. We're going to use the quadratic formula. In order to find the 2 imaginary. Negative b will be positive 2 plus or minus square root of square b, and we get 4. Minus 4 times a times c. All divided by 2a, which is going to be 8. So I have 2 plus or minus the square root of 4 minus 16 is negative 12 over 8. 2 plus or minus, that would be 2i roots of 3 over 8 divided through by 2. 1 plus or minus I roots of 3 over 4. And so your other 2 solutions are 1 plus or minus I roots of 3 all over 4. If you were then to write this in factored form, we have x plus 1/2 times x minus 1 plus I roots of 3 over 4 times x minus 1 minus I roots of 3 over 4. So maybe you can understand now why I wrote as x minus in the previous situation. That way we don't make that mistake. This is not quite complete, though. If you notice, there is something special about the rational or the fundamental theorem of algebra. It does say that there may need to be a coefficient out front. If you consider this problem here, if you multiply the x by x by x by x, you did get this x to the fourth. Notice in this situation, if you multiply the x by x by x, you get x cubed. Well, we want 8x cubed, so that's the true factored form. You can always stick a constant out front. And the last one, I have the total solutions. I have the positive real. I have the negative real. I have the total real. I have the imaginary. I have your choices. I have the solutions. And other than the solutions, I have the factored form. And so as we work through this, our total number of solutions, as you can see, is going to be 3 due to that exponent. As I determine the number of positive real solutions, I look for 1 sign change, 2 sign change, 3 sign change. So there are 3 positive real solutions or less by a factor of 2, so 3 or 1. I will now determine p of negative x. Negative 2x cubed minus 13x squared minus 26x minus 10. The number of negative real would be then 0. 3 plus 0 is 3, and 1 plus 0 is 1. This does not factor. I must use the rational roots here. Before let's determine our imaginary. Sorry about that. This could get confusing for people. If there are 3 total real, that would mean that there was 0 imaginary. If there was 1 real, that would mean there would be 2 imaginary. So this one is less descriptive. The other 2 I was able to figure everything out from the beginning. This one, a lot less information is given to me. My choices, I have 1, 2, 5, and 10. And here I have 1 and 2. So my choices will be plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. And I have to divide by 2. I get plus or minus a half. 2 divided by 2 is 1. Already have that listed. Plus or minus 5 halves. And then 10 divided by 2 is 5. I already have that listed. So we can just try something. As I look here, there's no negative real solutions. So I'm going to keep that in mind. I'm not going to try negative 1. I'm not going to try negative 2. I don't like the way that 1 looks right now, but I'm going to try 2. See how that works. I know I've done this problem in previous years. I can't remember for sure what works. I'm using a best guess. 2, 4, negative 9, negative 18, 26, and negative 18 makes 6, no, 8. Sorry about that. 16, nope, that doesn't work. That was unfortunate. Could try 5. If that doesn't work, I'll probably try a half. Two, 10, negative 3, negative 15. 11. No go. Try a half. 2, negative 13, 26, negative 10. 2, 1, negative 12. negative 6, 20, 10, 0. Looks like 1/2 works. If 1/2 works, I'm going to write this as x minus 1/2 times 2x squared minus 12x plus 20. Notice that I can factor out the 2. 2 times x minus 1/2 times x squared minus 6x minus plus 10. X squared minus 6x plus 10 does not factor. It's a quadratic. I'm going to use the quadratic formula. Negative b plus or minus the square root of. B squared is 36 minus 4 times a is 1 and c is 10. Divided by 2a. 6 plus or minus. 36 minus 40 is negative 4. So 2i over 2. 3 plus or minus I. So 3 plus or minus I. So the factoring would be x minus 1/2, x minus 3 plus I, x minus 3 minus I. And notice we're going to put a 2 out front because it all has to multiply to 2x cubed. So what did we learn in this scenario? We learned that we had no negative real. We did have one positive real. It was 1/2. It's located right here. We had just that one real for a total of 2 then imaginary, which are both right here. That's a total of our 3 solutions. That's the fundamental theorem of algebra moving kind of forward. Now we're going to move it the other way. This one says write an equation for a polynomial with solutions 4 and I. If there's a solution of 4, that means that x minus 4 is a factor. If there's a solution of I, that means x minus I is a factor. And we know that all imaginary solutions come in pairs. So negative I is also a factor. This is a polynomial. We will go ahead and write it out. X minus 4 times x minus I times x plus I. I'm going to multiply these two. X minus 4 times x squared minus xi plus xi minus I squared. Notice those cancel. X minus 4 times x squared, that will be a plus 1. And now you can multiply these out. X cubed minus 4x squared plus x minus 4. That is a polynomial that has solutions of 4 and I. There's technically an infinite number that have solutions of 4 and I because you can multiply through by any constant and it would still have the same solutions. But there you go. And our last example. Write an equation for polynomial solutions negative 3 and 4 minus 2i roots of 3. If 4 minus 2i roots of 3 is a solution, so is 4 plus 2i roots of 3. This example, it takes a while. It's not difficult. It's just we have to be patient. X minus negative 3, which can be written as x plus 3. X minus parentheses 4 plus 2i roots of 3. And x minus parentheses 4 minus 2i roots of 3. I'm first going to distribute my negative. So I have a negative here, I have a negative here, I will distribute those. X plus 3 times x minus 4 minus 2i roots of 3. X minus 4 plus 2i roots of 3. Now it's time to multiply them out. I have this x plus 3, x times x, x squared. X times negative 4, negative 4x. X times 2i roots of 3, 2xi roots of 3. Negative 4 times x is negative 4x. Negative 4 times negative 4 is positive 16. Negative 4 times 2i roots of 3, negative 8i roots of 3. Again, I know when you write like, this 2xi roots of 3, it just all seems really weird. Don't worry, folks. It's all going to take care of itself. It won't be bad in the end. All right, now we move on to the negative 2i roots of 3 times x, and we get negative 2xi roots of 3. Negative 2i roots of 3 times negative 4 is positive 8i roots of 3. And then the last one. This one is where people get a little bit messed up here. Negative 2i roots of 3 times 2i roots of 3. Negative 2 times negative 2 is negative 4. I times I is negative 1. And root of 3 times root of 3 is 3. That gives me a positive 12. Okay, looks really bad. We come to save the day. 8i roots of 3 and negative 8i roots of 3 are gone. 2xi roots of 3 and negative 2xi roots of 3 are gone. What you're left with is x plus 3 times x squared. It's gone. Negative 4x and negative 4x make negative 8x. And 16 and 12 do make 28. Now we can easily multiply that out. X times x squared is x cubed. It'll be a minus 8x squared plus 28x. Move on to my 3x squared minus 24x. And then 3 times 28 is in fact 84. X cubed, gone. Negative 8x squared and 3x squared is negative 5x squared. 28x and negative 24x is 4x. And then 84. That is your polynomial. That has solutions of negative 3 and 4 minus 2i roots of 3. There you have it, folks. The fundamental theorem of algebra. It's my favorite unit. Enjoy it. Should be a few questions from this worksheet. Let's go over them together.